Welcome to another episode of We Are Carbon. I'm Helen Fisher and I'm joined by Sophia Hamblin Wang of MCi Carbon to discuss their engineering technology that's transforming carbon dioxide into solid, valuable building materials. It's a little different for us to turn our attention to industry, but there's a beautiful parallel to regenerative agriculture here in that we're shifting to see CO2 as an asset that feeds our plants or, in this case, could build our homes. We hear a lot of noise about the need to meet net zero targets in the near future, but for many industries there simply isn't a clear path yet to getting there. MCi are looking to change that with a particular focus on difficult to abate yet highly depended upon sectors including steel, cement and mining. As a pathway to transition to a net zero future, they're utilising technology to speed up mineral carbonation. As a natural process, CO2 does become bound and locked into rocks, but it takes hundreds of millions of years. You can learn more about the process itself in the episode on accelerated mineral weathering with Kelly Earhart, so I'll pop a link to that one in the description. But within their engineering plans, MCi are speeding up the process to mere minutes. They can take flue gas emissions and bring that CO2 into a circular economy, by utilising it as a significant ingredient within a wide range of materials, including high-value plasterboards and cements and concrete. This is intentionally highly scalable and designed to work with industrial partners to build out localised circular industrial ecosystems. And it's all motivated by profitable models without the need to lean on carbon credits or subsidies. There's a huge amount of potential here, and it was a great pleasure to dive into the details with Sophia. New episodes of this podcast are added every other Tuesday, and they're available in both video and audio-only formats. You can find them on YouTube and your favourite podcasting platform. So don't forget to subscribe to keep up to date. Right, let's get stuck in. Welcome, Sophia. It's a great pleasure to have you here today to talk to us, and I think if you could just get us kicked off with a quick introduction to yourself and also to MCi Carbon.
Thank you so much, Helen. The pleasure is all mine to be here. So my name is Sophia Hamblin Wang, and I'm the COO of a company called MCi Carbon. We're a technology platform that transforms carbon dioxide into building materials and other valuable products for the circular economy. I'll talk a lot more about MCi, but I guess I'll just begin by telling you what motivates me and what my purpose is. So I joined MCi almost 10 years ago now, and I was actually doing a PhD in corporate social responsibility. So my passion and my academic area was in creating business models that make the world a better place. And I've dedicated basically all of my work in creating those business models in order to achieve broadly the Sustainable Development Goals. And MCi has been just an unbelievably rewarding place to work. And so I joined as the very first employee. There were the two co-founders who thought of the idea, and then I came on board to negotiate the research collaboration agreements, hire the team, and get the project off the ground. And now we're a technology that's based in Australia, and we have around 45 employees, mostly chemical engineers, process engineers, and geologists.
It's really very exciting. It sounds like a wonderful opportunity for your own career, and that things have moved very quickly since that starting day.
Well, I really have had I'll have to say, like a very accelerated career path working with MCi. The really being able to talk about industrial decarbonisation and commercialising technologies that are going to help the world to get to net zero. That message has really connected with a lot of audiences, and through my work with MCi, I've been able to present at the World Economic Forum in Davos. I've been able to be promote the technology on a lot of world stages. And I think now both my voice and MCi's voice have really been strengthened. So we're really featured on a lot of the biggest forums in the world talking about net zero technologies and the circular economy. So I have to say I've been extremely lucky, and I always look to help other people to build their careers in the space as well, because when I made the brave decision to quit my PhD, the industry really didn't exist. So it was really really taking a gamble and believing in the technology and the business model and the team. And there's still an element of the technology still needs to be developed a bit more, but it's really looking positive, and it's really exciting to be able to talk to you more about it today.
Yeah, how exciting indeed. It sounds like it's really paying off, and I'm just delighted for this. It's a slightly different topic for us in terms of we're talking about manufacturing and industrial production and moving that in the direction of being circular and net zero. And because it's just that little bit different, I think it would be a fantastic sort of setting the stage for us if you could maybe touch on some of the challenges that do exist within these industries. How can a business, for example, a manufacturing business, meet net zero goals? How can they be circular when they're sort of really driven by this sort of fossil fuel and pushing things forward in sort of dirty industry, if you like? So maybe if you could just sort of give us a very sort of high level overview, and even if it just touches on some of the production lines that you offer solutions to.
Absolutely. So I'll talk a little bit about what a net zero future is going to look like and what the transition to that future also looks like. So we know that in order to fully decarbonize our economy, we're going to need to do a variety of things, including electrify everything and apply many different technologies into the energy sector. But we also have this really important problem and opportunity, which is decarbonising the hard to abate sectors like the steel, cement, chemicals, and mining industries in particular. And also, if we are to overshoot our 1.5 degree target, then we also will be needing to suck CO2 out of the atmosphere in the future. And if you are to suck CO2 out of the atmosphere, then you need viable places to either store or utilize that technology. And so MCi Carbon has been developing a technology platform that can operate to decarbonize or create a viable solution into these different fields. Now, we've chosen to partner with the steel and cement sectors in particular because a lot of people don't really understand or realize that the steel industry has heat processes that aren't easily decarbonized through electrification, and alternative technologies are going to take 10 to 20 years to develop. And also the cement industry, the largest part of the emissions from the cement industry comes from geogenic emissions. So it's actually the CO2 is released from the calcining or from the process of the creation of the cement itself. So these key two products will have carbon emissions so long as we as a society need steel and cement. So sorry if that's being a bit too basic, but we really do both need to build infrastructure for the future and also find ways to decarbonize that infrastructure. What MCi Carbon does is we partner with those industries and take the emissions and turn the emissions into new materials, so create whole new pathways. And I can go into that a bit more later. What the manufacturing industries are doing right now is they are understanding the full supply chain carbon footprint of their products. So they're understanding what their suppliers and their customers are emitting, and they're really getting down to the truth of what the emissions profile is of their product. And as we start to have full information, validity and integrity, then customers are going to start to make decisions based upon that proper data. And as that starts to happen, then companies are going to have pressure to both decarbonize and also see a real opportunity around the marketing of those products as well.
Yeah, no, that's wonderfully explained. So these two very significant building materials, steel and concrete, which most people would acknowledge they're essential to the way that we build today, to the way that we know how to build. And we use them in vast quantities. We hear quite large numbers about the amount of emissions that come from the construction industry, huge percentage across the globe. And what you've just sort of outlined there is that steel can't be manufactured from solar power, for example. You can't take that route of renewable energy because it cannot be produced from electric. Yeah,
that's exactly right. Yes.
Yeah, and then on the other hand, the concrete, it's not about how it's powered. It's just an actual chemical reaction within the process, producing those emissions. And of course, if the transparency that you described, I think that's the first stage to anything, isn't it? Identifying how much is being actually contributed throughout the whole of that supply chain. So that is very fantastic outline for us. That's really helpful, certainly helpful to me. So taking that sort of into the idea of what you're doing, you're taking carbon dioxide, which is a gas, and actually converting that into solid bulk materials. And before we look into the applications of those materials, I think it would be fantastic if you could offer a little touch point on how that's actually possible.
I'm always happy to talk about the science. So MCi, we're really our core focus and what we're really good at is making the minerals really absorbent to CO2 and focusing on getting the CO2 to be locked away into the mineral. We take a variety of industrial wastes or virgin feedstocks, and we react those minerals to CO2, and that creates a solid output. And then we work with large industrial customers on those solid outputs. So I'll use an example of serpentinite, which is a magnesium silicate rock. It's highly abundant in the Earth's crust. It's an ultramafic rock, and I know you have covered enhanced weathering in one of your other episodes. So I know that your audience has a good basic understanding already. But we take magnesium silicate rock and then we pre-treat it. So we'll crush and grind and heat activate that mineral. And then we will process it in our state-of-the-art reactor that we have running every day in Newcastle, Australia. We'll combine that rock with water to create a slurry, and then we will bubble the CO2 throughout that slurry. And it's the bubbling of the CO2 through the rock mixture that makes the rock absorb the CO2, and that will create magnesium carbonate and silica. And those are our two key outputs. Now, the magnesium carbonate, we have a plasterboard or drywall application. So this block that you can see here, it was carbon emissions a month ago from an ammonia plant, and now 50% of this block by weight is CO2, and it's a negative emissions building material. So that's quite exciting. And then with the silica, we work on novel cement applications. So it's a supplementary cementitious product, and this block here is a 30% silica product from our process, which means it's a 30% reduction in emissions. For every ton of cement that's created in the world right now, 1 ton of CO2 is released into the atmosphere. So with this block, for every ton of this that is created, we're stopping 300 kilos of CO2 from going into the atmosphere. So that's just a basic example of one of the pathways that we do, but it's a really good one to show the way that our platform works. It's we can take a variety of inputs to create a variety of outputs.
Yeah, no, that excites me. I find it really interesting the way that it's kind of bespoke to the situation that you need. And it's also very exciting to see them there in your hands. I know a lot of people will be listening rather than watching this, but that is just to think that that's the problem we're all talking about, the emissions in the atmosphere, and now it's there for you to hold. But not just to hold it, it's actually replacing the need to make a product that would otherwise have emitted, and that kind of ties, sort of, it accentuates the impact, doesn't it? It's really very fantastic.
That's exactly right. So we should be focusing on embedding the emissions into a product itself, so doing something with the emission, but also displacing downstream high carbon intensity inputs. Which is why we can say that this is an exciting carbon negative material.
Yeah, fantastic. And like you said, we did have an episode, and I'll make sure that that's available for people to look at if they'd like to consider that process from its natural point of view, mineral weathering or accelerated weathering, as we spoke to Kelly Earhart about that. And in this discussion today, we're focusing on the material application. So rather than just accelerating that process, how do we actually repurpose those emissions to replace some of the products that we actually need? And I think that's really very exciting.
Absolutely. And I think the key point is that it will take 1,000 different technologies in order for us to get to net zero. And different technologies are applicable and suitable in different locations with different economics. And the key difference between what we do and what the enhanced weathering application does is, although it's based upon pretty much the same chemistry in that, the Earth naturally absorbs CO2 over time, and we are an engineered ex situ application. So we take rocks and we carbonate them in an engineered way, in an engineering plant. But because we do it that way, we're able to scale up into the billions of tons of CO2 locked away in the future. So we really created purposefully from day one a business pathway that would be able to lock away billions of tons of CO2. We, every step of the way, we've chosen to partner with the industries, with the feedstock providers, and with the CO2 providers that can allow us to get to that, the mega and gigaton scale.
No, that is so, it's phenomenal numbers. It really is very, very extraordinary. So in terms of the process itself, nature knows how to do that. Nature sort of designed that as part of this very, very sort of millions of years, if you like, sort of carbon cycle, where the atmospheric carbon gets dissolved and integrated, attached to the rocks, and then it's permanently held there. And then when we spoke about accelerated weathering, that was in a sense, in a nutshell, really oversimplifying it. The process was accelerated by deliberately breaking down those rocks and making them very, very small particulates that then was exposed to the carbon in the water. That accelerated it vastly. That was a huge acceleration. But what you've done is taken that even further in terms of time and the speeding up of that process through putting it into an engineered setting with equipment, and you're bubbling the carbon dioxide through the material, and it's fixing to those feedstocks. And yeah, those numbers are very difficult to grasp. I think when we talk we talk into the millions and the billions. I don't know if it's just me, but it's hard to sort of picture it and get your head around. But I think it's very, very significant, and everything's going in the right direction.
Helen, you're absolutely right. And what we've done is we've taken the process from millions of years into minutes in our pilot plant. And then once the carbonate is produced, then we're putting it into the built environment. So we're putting it to good use, and we're making money from it, which is another key thing, because what we understand about scaling climate technology is that if you have a viable business model, then you can proliferate the technology much faster than just waiting for industries to do it out of the goodness of their heart or from some moral obligation. So we've really tried to focus on doing that which can be adopted quickly as well. Not that other enhanced weathering technologies are not doing that. Like I said, there are so many really great technologies out there. We're just one of them. Yeah.
It's like, I think everybody in this space, they acknowledge the need to do multiple solutions, everything that we can side by side. That's what it's going to take. And this is a really fascinating, like I say, it is somewhat different to what we normally talk about, because it's, we often on the podcast, we're talking about working with nature and regenerating with nature. This is, it's a wonderful sort of way of sort of bringing that into it, because it is still using the chemistry that nature provides to us, but repurposing that in our own hands, putting the control in our hands to fit into the society that we've built, which is, it is what part of the problem, isn't it? Is that we're trying to slot such a dramatic change into a system that is perpetually moving forward. It can't put the brakes on and stop building and stop increasing the population and the need to build. So yeah, every single opportunity is a really big part of the puzzle. If I could, I'd love to just sort of outline a few of the details of the opportunity that is here. So you've shown us a product, and I think you maybe touched on this already. The plasterboard was 50% by weight CO2 emissions.
Yes.
So that's, I was going to ask you, how significant as an ingredient is that CO2 within those materials? So it's a pretty high percentage, yeah?
Yes. So the applications of the CO2 obviously range from a smaller percentage with higher value applications, all the way through to higher percentages in less value applications. So I think the plasterboard drywall magnesium carbonate product is compelling because it's high value and high carbon input, and so that's, I don't know, it's really exciting because CO2 as an ingredient is quite useful, and as soon as you one of the principles of the circular economy is that there's no such thing as waste. There's only molecules in the wrong time, the wrong place, and the wrong shape or phase. And so as soon as you stop seeing CO2 as a hazardous waste and start imagining it as a valuable input, then it does unlock lots of alternative uses. And so our chemical engineers and our team have really been looking at every part of our life, that everything that we touch in our house, in our industries, even in our built environment largely, and really thought about where we can embed carbon emissions, and that's really important for the transition in particular.
Yeah, and that outlines really what I see as the connecting kind of theme here to the other things that we speak about. There's this huge parallel. It might not be obvious because we're talking about industry, but there's a huge parallel with regenerative agriculture because we're sort of taught to see carbon as an asset. Carbon is a building block of life, carbon is plant food, and in this case, carbon is this valuable ingredient that builds the materials that we need. And that's really fantastic. The other thing I'd like to sort of just dig into, I suppose, quickly, because I think it's something people will sort of be thinking through the process themselves. You are still using a factory setting, so it's still industrial production. You've got a big space, you've got presumably equipment to run and operate. So in that regard, is the CO2 that's being drawn into the product and utilised, is that vastly outweighing what is being taken to operate the facilities?
Yes, fantastic question. So we, from the very first day that we started the company, we have always been intentionally carbon negative. So we do full life cycle assessments from go to woe to ensure that we are locking away more CO2 into the products than we are burning in the process itself. Now, obviously, the carbon economics, or to use a bit of jargon, the techno-economics of our process can vary depending on which industries we're plugging into and which applications we result in. So, with that caveat, we are one of the best people in the world to assess and to deliver carbon negative pathways for industry. We would be co-locating with the steel, cement, mining, and chemicals industries and producing the outputs. And I think the large amount of the outputs would be extremely carbon negative.
Yeah.
So, I mean, the different industries have different carbon negative or carbon neutral appetites. And so that's been quite fascinating from my perspective, is talking to different industries about how quickly they want to decarbonize and how much they would like to invest in order to unlock the really big opportunities. And yeah, we're well down that path now.
Yeah, no, that is interesting. So there's certain materials in particular that are more eager than others, so to speak.
Yeah, I'd say so. And in particular, we just took some investment and an accelerated customer in RHI Magnesita, which is the largest refractories company in the world. And so they build, they provide the refractory bricks to line kilns for the cement and steel industry. And that is a whole new product application that we hadn't really anticipated when we first started the organization. But absolutely, the refractories industry need pathways to decarbonize. They have also geogenic CO2 from their process. And MCi is, they did a global search and chose MCi as their the number one technology to decarbonize their industry. And so different industrial customers and pathways have different risk appetites and different investment appetites. And we've been really fortunate to have found customers and partners and funders that are in it for the long haul. They're willing to invest in technologies that are going to take more than 5 years to make a return on investment, although it's not much more, but still it's more than 5 years. And so we're really, we've been looking for the industrial customers that understand that and who can help to fund us and be a part of some part of the carbon supply chain that we're creating.
I find this bespoke sort of side of it actually really exciting. I don't know if it's just, it feels like there's so many opportunities, so many options. And like you say, you speak to different people in different industries. They know their industry inside out in ways that you couldn't imagine utilizing this. They can sort of tie you in with that. So it can ever evolve by the sounds of things. And I think because it becomes complicated when we start to think about all of the different potentials. But to outline this, the carbon dioxide as a key ingredient, it then has to be attached to a feedstock essentially. And those feedstocks are what can vary. And you've mentioned that you can have low quality quarried mined materials, basically virgin materials can be quarried for this. You also can use waste materials. And I think that's another aspect that seems so beautiful in making this circular, is that the sort of feedstock also can be a waste material. Could you maybe touch on a few of those feedstock options and how they might impact the potential applications that they're suitable for?
Absolutely. So the basic chemical reaction that we're doing is we're attaching the CO2 to a magnesium or a calcium molecule, as our key pathway. That's creating magnesium carbonate or calcium carbonate. And so the key industrial wastes that we are working with our customers on are steel flags and incinerator bottom ash from the cement industry, and also mine tailings. And the biggest opportunity in many respects is in the nickel industry. We've got key magnesium pathways there, but also there are applications in the lithium and cobalt industries too. And we know that the transition minerals and metals are the most important to decarbonize because they're the key metals that are going to get us to net zero. So MCi has focused on minimizing the tailings waste from the mining industry and steel slags and cement waste. Now, the applications obviously vary based upon which industry it is, but in the steel industry example, we create a precipitated calcium carbonate, and that is quite an exciting application and quite high product markets and product confidence. And all the way down to lower value applications within the mining industry, where we would look to create lower quality, just even backfilling mines and other low quality pathways. It still ends up being carbon negative and economically viable, even if you are just remediating the mine site itself.
Okay, so at the one hand, that calcium carbonate can be very sort of pure, and that can become a plasterboard, for example, and that can be utilized within the construction of a home or a building. And on the other hand, you're locking the CO2 emissions into waste that's coming out of the mine to then remediate that mine in a positive way, because it's taking some of those emissions back in with it, and then presumably helping to put the site in good order after it's been quite sort of manhandled and torn to pieces. So that is a very vast range of applications.
And Helen, that it so I don't want to overwhelm you or the listeners because there are so many applications that we can do. But the core focus is on fixing the CO2 into the mineral and doing that in the maximum amount of quantities as possible. But one of the key things that we've been trying to do is partner with industrial sources of CO2 in this short and medium term, because we want to be stopping CO2 from going into the atmosphere right now. We really want to focus on stopping emissions right now. But in the long term, we can absolutely be partnering with direct air capture technologies once they are scaled up and viable. And in that time scale, we can be just sucking CO2 out of the atmosphere and locking it straight back down into the earth at minimum, but ideally with downstream uses. But when you're looking at trying to remediate climate change and really stopping using the atmosphere as a sewer and start cleaning it up, then we have to be open to a lot of different applications. And so that's really where I see the short, medium, and long-term applications of our technology.
Yeah, and it seems like there's so many technologies being developed side by side, like you've discussed or you've mentioned there, the direct air capture, and saying that when that develops further, when that's ready to be scaled up. So there's so many different things that are in fact in motion and under development. So you are currently seeking the CO2 as a waste product. What is your main source for the CO2?
So the main sources that we are looking to integrate with the steel, cement, and refractories industry. But did I mention that we're about to put shovels in the ground for our demonstration plant in Newcastle? So
that's exciting.
Yeah, so we will be locking away between 1,000 and 3,000 tonnes of CO2 per annum in that facility. And the facility itself, it will be built next to an ammonia factory. So we'll be taking the CO2 from that facility, but the integration will be built with flue gas, with a flue gas synthesizer. So the idea is that when we work with a steel slag customer, they will provide us with their mineral, and then we will ask them, what's your composition of flue gas, what percentage CO2, NOx, SOx, etc. They'll tell us, and we will simulate that flue gas in our process and create the key outputs so they can validate the business model and the techno-economics, and then decide to build the scale-up version of that plant at their facility. And so that's how we will be running our plant. And it's super exciting because we just got DA approval, so we will be putting shovels in the ground any day now in Newcastle.
Very, very good. So the CO2 is directly coming from the flue of the manufacturing,
and yes, so in this case.
I like this. It's kind of taking us off as more opportunities, more things to consider and get our minds around. But I find it really interesting and exciting because when we think about being circular, we've got to keep those building blocks in motion. They're no longer going to be considered waste. They're being transformed, reutilized, taken back round. And that can be a natural compost process, or in this case, a more industrialized process. And something that we come across a lot in grassroots initiatives that really helps things become circular is the idea of community and having localization. And what you're describing is kind of the industrial version of that. It's like an ecosystem of businesses. So you've got the plant that has the processing of the CO2 gas and attaching it to the feedstock. But then in close proximity to that, you've got some other business that is producing the waste and also the gas. So it's feedstocks and gas in close proximity coming to you and then keeping that in motion. So do you then have partnerships in the ideal sort of future sort of built up scenario that then the material that you provide goes to a local manufacturer of whatever that kind of suits?
Absolutely. So there's two key things I want to pull out of that. One is that we need three things to be successful, and those three things should be around 100 kilometers radius of each other. We need a source of CO2, and that CO2 can be flue gas or low quality CO2 down to around 15%. We need a feedstock, which has either magnesium or calcium in it. So it can be a low quality virgin material or it can be an industrial waste. And then we need a local market to buy the product. And if we have those three things, then we are economically viable. And by the way, a carbon price is just the cherry on top. It's not what we rely on in order to be profitable. So yes, we do need a local market, but one of the things that we're really good at and one of our core capabilities is in looking at what local markets exist, what amount of product we could be putting into existing markets, but also what new products could be unlocked if there were negative emissions profile materials that became available. Because you don't just have what's in demand right now, but you also have to imagine what might be in demand in the future if you had a magnesium carbonate product that was negative emissions profile that could displace other things. So that's one key point. The other is around communities, and we have always talked about the industrial ecology of our process. Now, we really do bring together a lot of different industries into one, and we bridge the circular carbon economy bridges a lot of different industries together, and it takes a little bit of rejigging in some respects in order to unlock the real synergies and the value. But it's a real pleasure to do that as well, because sometimes a steel customer is close by with a cement customer, but they never really work together. And if you had a carbonation facility near both of those things, then there could be, whole new opportunities unlocked. So we really look at the industrial ecology and how different things will integrate, and try to find pathways to make that possible. In Australia, where we have where our demonstration plant is going to be built, it's the largest coal port in the world. We have our workforce, our 45 people workforce, who are mostly chemical engineers, geologists, and process engineers. Most of them have come from the coal industry or coal aligned industry, and have reimagined and repurposed their careers in order to work on technologies that are going to be part of the climate solution. And so we've really tried to create values alignment with our employees, with our customers, and with our investors on ensuring that we're all on the race to net zero, and where we are also actively looking at what sort of future industry are we going to have in the transition. What sort of jobs are we going to have in Newcastle and all around the world? What sort of jobs are we going to create in the communities that may be experiencing a downturn when we have a less reliance on fossil fuels? And so MCi Carbon's business model and our core the features of what we do in transforming minerals into sustainable minerals. It's around bulk processing and materials handling and sustainable engineering. And these are key capabilities that will be accessing people and communities that kind of need just transition pathways. So and that's something that motivates me as well.
Yeah, the people side of it is huge, isn't it? That need to have consistency with job availability and development of their careers and purpose-driven careers as well. That's very lovely. I would like to touch on the applications. We've done this already, but I just kind of want to just throw it out there and just see how broad it can be, because we've talked about the construction materials and the plasterboard and the cement potential replacements. But am I right in thinking it can also sort of suit for pharmaceuticals and other sort of quite different variety of products?
Yes, so there are applications that we've worked actively in things like carpet backing, in washing detergents, and paper. And I tell you that there are so many different applications. Obviously, you can place the carbonates into pharmaceutical applications as well, and there are a myriad of lower scale, higher value applications. And MCi Carbon hasn't focused on those just because of the scale aspect, but there's no reason why we couldn't in the future. And also, there's probably some other amazing companies that are focusing on that.
Yeah, so they're very versatile ingredients that you're producing. And in essence, the MCI carbon plants would be a hub in the center of a sort of ecosystem. Um, you produce, it's like an ingredient for a manufacturer to then take on. Is it like a powder that you create?
Yes, so we create two key powders, the carbonates and silica, and we work with the largest cement, plasterboard, carpet, the largest manufacturers of those products in the world on novel applications of their novel formulations of their materials, and also just validating that the products that we produce are equivalent to what they're already using, if not better. So that's actually really working out well as well. We've had a lot of validation from our industrial customers, and probably in the next month we'll have some publicly available statements on that. Yeah.
Yeah, that's really exciting. So you've essentially developed a sort of experimental plant. This is the place that you're at currently, where you've got your location plan and it's going through the whole process on a smaller scale, but then you're working with a multitude of partners to explore. And what you see as the long-term vision is replicating that, but to specific locations that are well suited and have those three aspects needed: the plant itself, but then the CO2 source, the waste source, and the customer that can then manufacture the product. And you said within 100 kilometers, is that correct?
Yes, I mean that's a rule of thumb at the moment, and that's a 2023 assessment. And if that location is proximate to a port or a key rail line or a CO2 pipeline or a hub, then the carbon economics change. But I think it's just helpful to, as a rule of thumb, to say it has to be vaguely in the same area
Yeah, it does help.
because you don't want to be creating carbon negative magnesium carbonate in the middle of nowhere and then losing all of the carbon benefits by having to freight it, hundreds of kilometers away. So, the localization aspect is going to be key in order to make sure that we're getting the maximum climate benefits out of what we do.
Yeah. And within this model that you've kind of got in mind, do you have a sense of the scale of the businesses that would need to be involved?
Yeah, so we're looking at the next plant that we'll build will likely be in the EU, and that will be around 50,000 tons of CO2 per annum, and that's quite a viable plant, it's looking like, and then anything from there is getting more economically favourable. Common plants that we will build with customers will be from the 100 to 250,000 tons of CO2 per annum. And then we are also, we're scoping out a plant at the moment and understanding the viability of a 2 million ton of CO2 per annum plant. And it can actually go up to even larger, like in the 20 million tons of CO2.
Well, so, just for one plant?
Yeah. In one plant, in one location. Yeah. And you really unlock those opportunities if you are looking at carbon hubs and different industries coming together as well. So I hope that answers your question okay.
It does, yeah. So it's very broad. The potential is obviously enormous. So you mentioned about the fact that carbon credits, carbon markets are sort of a cherry on the top of all of this, which is in itself quite an interesting aspect, because that in some instances the only motivation to drive businesses towards net zero. So you're building a very unique motivation for companies. Do you feel that sort of it has the potential to really evolve the drive towards net zero?
When I joined MCi, when we received our first $9 million worth of funding, we actually had an emissions trading scheme in Australia. And there was a real impetus and a legislative penalty for industrial companies to look at their emissions, stop their emissions, and also understand what they would do to decarbonize. And so we had a real clear mandate with our potential customers back then, and then our government changed and the emissions trading scheme was repealed, and we had a very unclear time from 2014 onwards for a while, a very long while. And what I'll say about that is that having a price on carbon provides a really clear policy certainty and a clear direction to companies and to carbon technologies that are trying to build and grow. So we were very clear in that very, very turbid time that we couldn't rely on a carbon price because so many things can change in the global economic environment. So we really focused on our downstream value in order to have a viable business model, because carbon price can change, things can be taken away from you pretty quickly. And so we're really grateful that we did that, because it's really set us apart from a lot of the alternative technologies that exist that do just rely on a carbon price in order to be viable. We just don't see the access to capital as being enough in order to scale. The other thing is that some other technologies that exist, they rely on carbon economics that stipulate having free renewable energy as the input into their technology in order to be viable. And we really haven't done anything like that. So our life cycle assessments are based upon really reasonable scale out access to a variety of different energy inputs. And so that's based upon the different locations. It may be, with some gas-fired power, etc., with still a carbon sink, still carbon negative, even not relying on renewable energy. So then when we do scale out with our customers, they've got really reasonable and realistic expectations about what our technology can deliver. And then when there is ubiquitous free renewable energy, then that's also just adding to our economics. And so I think it's just really important to be very open about the way that you do those equations, because you just can't rely on ubiquitous free renewable energy as an input in order to be carbon negative.
Yeah, absolutely. It's just not where we're at right now. So these are profitable business models in and of the actual process itself, not because of the sequestering of the carbon.
That's right. In obviously with the caveat that different locations have different economics, but yes, by and large, that's the rule of thumb.
Yeah, fantastic. So
can I also just I forgot to mention before that the carbon block that I carry around as the example of, touching the carbonate and understanding that this used to be CO2 and now it's a building material. I can build my house out of it and I can turn it into profit. I took a suitcase of those bricks to Glasgow to COP26 and got to showcase them there, and also competed in the Net Zero Technology Centre COP26 pitch battle. And there were 2,700 companies that entered into that, and we actually won first place. So the number one pitch at COP26, and I think that's notable because of the way that mineral carbonation technology can be placed as a decarbonisation black box into many different industries to unlock low carbon pathways for many different outputs. And I think it's that broad applicability that was the reason that we won. And also, obviously, talking about business models and the amount of money that can be made in this industry. Because at last assessment, in 2017. So I think there have been surely updates, but the source I can cite, in 2017, the industry was worth $5.9 trillion for carbon utilization applications. And so it's at least that. It's probably much more than that now, but in any case, there is a lot of money to be made from carbon embodied materials from carbon utilization technologies.
Yeah, you're making it both relevant and attractive to so many different people. That's really exciting. And I know you've received an awful lot of recognition for the work that you've done already. Maybe we could sort of wrap things up a little bit and touch on that.
Yeah, well, so the biggest one is the COP26 pitch battle. That was great because we also won the audience choice. So I have to say, like, as a personal career highlight, that was amazing because the world's cement, steel, mining companies had all committed to net zero by 2050, but none of them really knew how they were going to do it. They just made the pledge, but the path to action wasn't clear. And so COP26 was a real starting gun for us. and that was simply wonderful. And since then, we have won just an array of awards, particularly the Banksia Sustainability Award in Australia. We took out the number one circular economy technology there, and we are in the running for a number that may be announced in 2023. So both grants and awards. And we absolutely don't do what we do for the awards or the accolades, but it is so important to be able to communicate the full carbon economics upstream and downstream, your scope 1, 2, and 3 emissions. And we feel like if we're able to stand up and say, this is how we do it, this is how it's been embedded in our core business from day one, then it does provide a pathway for other innovative technologies that are coming up through the technology readiness level to really understand that it can be done and that you can be funded, and you can get customers and investors using that pathway. So that's why we've been really we've entered into a few of the awards. And by the way, it really makes our staff buoyant as well. So we're always looking for more people to join the team. If anybody does like the sound of MCi Carbon, please do get in touch because we're growing pretty quickly at the moment.
That's wonderful. Yeah, thank you. It's been hugely informative to learn about this, and it's something that isn't always easy for people to get a grasp of, what happens in an industry and how do we approach those pledges that have been made. And I think you've done this fantastic job of helping people to connect into it and find an understanding. You've kind of moved through the success of the development side and the demonstration site that you've got and really demonstrated that this works, this is ready now for the world. And you sound like you've got a lot of partnerships lined up, and sort of going through the process of that. How do people learn more, and how are you looking for particular people to get involved?
Yes. So one, we're always looking for the right values-aligned people to join our team to help our company grow. Although our technology has been demonstrated to be viable at the stage that we're at, we still have to grow through the valley of death. We're not there yet. So, in clean technology, it's been reported that it's not a valley of death. It's 3 valleys, if not a canyon of death. So, so it's just extremely important to have the right people on your team, also the right funders. We need access to capital. We're always raising capital from people who are looking to fund our pathway, and it's not as easy as just 1, 2, 3. It's really understanding the compatibility of the capital and the technology, and it takes time to do that. So if people feel like they understand it and want to know more, then please do get in touch. But the biggest thing that people can do is really understand that low carbon intensity and negative carbon intensity products exist, and use your wallet to vote for those products to be, 1, available on the market, and 2, the products that you choose. At the moment, carbon intensity of products isn't really communicated because there's not a lot of integrity around the information, and customers don't really understand the full scopes of the emissions. We need that to change, and we need the information to start being pulled through into consumer choice. And that will be both from people and also from governments legislating that to be something. So people need to be voting with their money on carbon low carbon products, voting with their money on low carbon products. And that would be the biggest help for MCi.
That's wonderful. Well, best of luck with everything. It's really interesting to learn, and I hope it all goes fantastically well.
It's been an absolute pleasure, Helen. Thank you so much for allowing me to talk you through where we're at and to get to know your listeners a little bit more. So that's fantastic.
And thank you for listening to this episode of We Are Carbon. New episodes are added every other Tuesday, so don't forget to subscribe to keep up to date. It's a huge help to the show if you'd like to add a thumbs up or a review on whichever platform you're listening on. And let's keep figuring this all out together.